Scientists just found out that the Earth's crust beneath the Marmara Sea is sending seismic signals that look exactly like the kind that show up before a major earthquake. An earthquake that can shake entire coastlines and send waves racing toward crowded cities. For years, scientists focused on visible ruptures on land because they could measure and map them easily. But now, they made a detailed map of a huge fault system under the seafloor. The Mediterranean already sits at a dangerous crossroads where massive tectonic plates meet. Those plates push, scrape, and stretch against each other, and that constant motion creates massive stress. The crust there grows thinner over time, and thinner crust means it can't absorb stress easily. Stress builds, pressure mounts, and the signals coming from below show that parts of this fault system have started to move in unusual ways. The new map shows that future large earthquakes may begin at the boundaries where weaker and stronger sections of the crust meet, or along edges of highly resistive zones. They even pinpointed one of the most likely locations, beneath the Marmara Sea. What makes this discovery so intense is the scale. The faults in the seabed form long corridors where energy can accumulate for decades or centuries. Scientists warn that this setup is the kind that can produce a super earthquake, a massive seismic event capable of shaking large coastal cities and possibly generating tsunamis. A tsunami forms when the seafloor shifts vertically and displaces huge amounts of water, so it looks really plausible in this setting. The water it sets free radiates outward in powerful waves that can cross entire seas. The Mediterranean holds dozens of densely populated shorelines, so it could affect millions of lives. Speaking of that, let's zoom in on Istanbul, Turkey's largest and most populous city. The massive fault line sitting right under it doesn't act the way scientists thought it did. For years, experts looked at the main Marmara Fault, a branch of the North Anatolian Fault running beneath the Sea of Marmara, and worried it might rip in one single monstrous rupture. That kind of break could unleash a mega-quake in the high 7s or beyond. But when scientists ran detailed computer simulations covering more than 10,000 years of earthquake cycles, they saw something different. The fault doesn't behave like one giant zipper waiting to unzip all at once. It behaves more like a row of connected tiles that break in sections. And the reason comes down to what's happening miles below the seafloor. It's called rheology. Simply put, how materials deform under stress, how rocks bend, stretch, or snap when you squeeze them hard enough. Under the central Sea of Marmara, giant piles of compacted mud, sand, and debris sit on top of warmer crust. In those upper layers, the sediment usually deforms slowly and steadily, especially at shallow depths where pressure and heat interact in specific ways. Deeper down, higher temperatures weaken the rocks. Warm rock flows more easily than cold rock. That heat acts like a built-in brake system that limits how far a rupture can tear through the crust. When researchers built a 3D earthquake cycle model, they fed in real heat flow measurements, rock friction data, and structural details, and replayed thousands of years of seismic activity. When they included both sediment thickness and temperature differences, the model finally matched history, including the powerful quakes of 1766 and 1912. And none of the simulated events exceeded magnitude 7.3. That level of shaking can collapse buildings, fracture infrastructure, and cause landslides. But it differs from the nightmare scenario of one continuous coast-to-coast rupture. Instead, different sections behave in different ways. The western segments produce more regular earthquakes, including magnitude 7.2 events roughly every 150 years. The eastern sections generate smaller double quakes, back-to-back events between magnitude 6.2 and 6.8 about every century, and a magnitude 7.0 roughly every 500 years. Parts of the fault don't snap at all, but creep. Scientists call it shallow creep, which just means the fault slowly slides without producing a major quake. It releases tension quietly, like letting air out of a balloon instead of popping it. GPS measurements and clusters of repeating small quakes over the past 20 years confirm that slow slip near the central basin. So what does this mean for Istanbul? A city of over 15 million people sitting practically on top of this system. A magnitude 7 or 7.3 quake close to the city could still rock neighborhoods, especially if two strong events strike in quick succession. Infrastructure, older buildings, and densely packed districts are at the highest risk. The fault hasn't produced a major rupture in this section since 1894, which means there's more than 130 years of accumulated strain. The simulations show major events could strike in the coming decades. Then there's Santorini, where more than 28,000 earthquakes happened in just a few months in early 2025. Most of the quakes stayed small, but some reached magnitude 5, strong enough to fracture walls, rattle nerves, and push authorities to close schools and evacuate parts of the island. And this wasn't just tectonic plates grinding like they usually do. This swarm moved. The epicenters shifted gradually northeast toward the Colombo submarine volcano about 5 miles offshore. That migration told scientists magma was on the move. Researchers calculated that roughly 80 billion gallons of it, enough to fill about 120,000 Olympic swimming pools, surged upward from depths around 11 miles beneath the surface. It climbed fast, then stalled about 2 to 2.5 miles below the seafloor. And all this was going on along the Hellenic Arc, one of Europe's most active subduction zones, where the African plate dives beneath the Eurasian region. Earthquakes often migrate across that span toward nearby islands. History backs that up. The 1956 Amorgos earthquakes unleashed massive shaking and a tsunami across the region. So, when 28,000 tremors light up the seismic network, you pay attention. This episode changed how scientists understand volcanic swarms. Now they know magma can intrude, fracture miles of crust, reshape underground reservoirs, and still never surface. It can load the system for the future without pulling the trigger today. And that matters because when magma moves like this, it changes stress fields underground and how future quakes might breed. The good news is that scientists now have really cool monitoring tools that feed real-time seismic feeds, underwater pressure sensors, and repeated gas measurements near volcanic vents into integrated hazard models. If magma starts accelerating upward again, researchers will see it and will take action. And there's another bold new idea in earthquake and tsunami warning: using undersea internet cables for this purpose. Nearly 1 million miles of those fiber optic lines on the seabed were designed to carry data, but scientists discovered that they can also detect tiny changes in light signals caused by seismic vibrations. In simple terms, when the ground shakes, the cable feels it. And this could be incredibly useful because forecasting earthquakes, even on land, is tricky. In the ocean, it has felt almost impossible as you can't scatter thousands of sensors across the seafloor easily. But those cables already sit there, stretching across deep trenches and continental shelves. If researchers use them as sensors, they can monitor tectonic movement in real time across huge areas. For a region like the Mediterranean, with hidden faults, active volcanoes, and crowded coasts, that system could offer precious seconds or minutes of warning. Seconds sound small, but early alerts let trains stop, gas lines shut down, and people move away from immediate danger. The fiber optic cable used for Seafloor Project, or FOCUS in the short version, didn't warn anyone about real disasters yet, but it had 2 false alarms. It reacted to a submarine landslide and weight bags that pushed the cables down. It proves the system works and could be life-saving in case of real danger, especially in vulnerable regions such as the Mediterranean. It shaped civilizations for thousands of years, and now science reveals it still shapes itself. They can't stop tectonic plates or cool magma chambers, but they can understand patterns, reduce vulnerability, and design cities smarter.
Now, history teaches us that the supercontinent existed a long time ago, around 300 to 273 million years back. At that time, all the continents on Earth were buddies and hanging out together. They formed an amazing crew called Pangaea, or Pangaea if you're feeling fancy. The name comes from a Greek word which means all the Earth. Pangaea also had a massive water neighbor called Panthalassa, so our entire world was a huge piece of land surrounded by a huge piece of ocean. The mega-continent looked like a giant sea, stretching between the tippy top and bottom of our planet. But as stories go, things change. About 200 million years ago, in the early Jurassic epoch, like dinosaur times, Pangaea decided to throw a breakaway party. Forget about the old ideas of continents just drifting around like big icebergs. It split up into smaller chunks, forming the continents we know today. Oh, and it created the Atlantic and Indian Oceans as a bonus. Pangaea's tale was first told by a German weather expert named Alfred Wegener in 1912. But how did he learn about something that happened so long ago? Imagine the Earth's core as a big, cozy fireplace, giving off heat. This heat creates special swirling currents in the Earth's outer shell. We can think of it as the Earth's crust, which looks like a big puzzle with many puzzle pieces. The hot currents make these puzzle pieces, called crustal plates, move around. Sometimes they push apart, sometimes they crash into each other, and sometimes they slide past one another. It's like a fantastic dance party that goes on beneath our feet. One day, Wegener looked at the shapes of the continents and thought that, hey, those coastlines of South America and Africa kind of fit together. And they really did. So he imagined that way back, all of the continents hung out together as one big landmass. But he couldn't just go and say that without any proof. So how do we know Pangaea really was a thing? Well, there are some clues that brought us to this amazing discovery. One clue is like when you put a puzzle together and the pieces fit just right. Take a look at the shapes of today's continents. You'll notice that they could fit together almost like a perfect match. Obviously, their shapes changed over time. It happened millions of years ago, and since then, the shores of continents have been washed by waters for years. But even so, we can still see how well they fit together. Another clue comes from checking out fossils. We know that ancient animals left a lot of fossils behind. That's how we learned their history and what species there were. But when scientists compared fossils found on different continents, they found something interesting. These fossils look similar. Surprisingly, they belong to the same groups of animals, even though they were far apart. It's not like these animals could swim across the ocean on their four paws. And it's unlikely that this particular type of animal originated in two places at the same time. And finally, the mountains. Imagine exploring underwater and finding huge mountains in the oceans. These underwater ranges and deep trenches are like scars from when Earth's tectonic plates moved around. They serve as another proof that the continents are part of something bigger. When you look at these things together, you get a pretty clear picture. The Earth's continents were once huddled together in the supercontinent. They've since gone their separate ways, but the memories of their grand adventure are still written in the shapes of coastlines, the rocks they left behind, and many more. But it's obvious to us now. At the time of Wegener's discovery, there were different ideas flying around. Some folks thought that the continents sank down to make the oceans, but Wegener had a different take. He thought that the continents are always on the move. He even came up with a fancy phrase, continental drift, to explain it. Later, he was joined by another scientist named Alexander du Toit. He added a little twist to the story, suggesting there were two original continents, Laurasia in the north and Gondwana in the south. But the real party didn't start until the 1960s, when scientists figured out the secret ingredient in this recipe, plate tectonics. And finally, this theory explained everything Wegener and du Toit talked about. Wegener's theory was proven correct after 50 years. As time passed, we learned more and more about our planet. We found out that the Earth used to have multiple supercontinents. Before Pangaea, there was a mega-continent called Rodinia around 1 billion years ago. And later on, Pannotia joined the scene about 600 million years ago. What's interesting is that the continental drift story is far from over. Our continents are always on the move. Africa is giving Europe a friendly bump, And Australia is playing a game of bumper cars with Southeast Asia. You know what's on the horizon? Another supercontinent. So, how will this next supercontinent come together? Well, there are 4 major possibilities: Novo Pangea, Pangea Ultima, Orica, and Amasia. These might sound like superhero names, but they're actually ways the puzzle pieces could fit. Let's look at them all. First, Novo Pangea. You know how there's the Atlantic Ocean on one side and the Pacific Ocean on the other? Well, if these oceans keep doing what they're doing now, the Atlantic will keep opening up while the Pacific squeezes in. If that happens, the Americas, North and South America, will give each other a big high five. And Antarctica, that icy land way down south, will join the fun too. It'll be drifting northward. Next, Pangea Ultima. In the future, the Atlantic Ocean might get tired of being so wide. It might decide to slow down and shrink a bit. The Americas and the northward drifting Antarctica will probably crash into Africa and Europe. And just like that, a brand new supercontinent forms. There are these spots where the ocean floor is sliding underneath the land. It's like a secret underwater passage. These spots are called subduction zones. So if these secret tunnels will be spreading and spreading all along the east coast of the Americas. The Americas, Europe, and Africa might come together again, and they'd form a supercontinent. This supercontinent would be surrounded by the Pacific Ocean. The next possible supercontinent is Orica. In this scenario, the Pacific and Atlantic Oceans might decide to take a nap and close up. But don't worry, because when one door closes, another opens. In this case, a whole new ocean would pop up to replace them. Imagine a big crack in the ground cutting through Asia, like a zipper opening up. This crack is called the Pan-Asian Rift, and it would become a brand new ocean. With this new ocean comes a new supercontinent, Orica. Australia is currently drifting northwards, like it's trying to find a nice spot at the center of our planet. East Asia and the Americas might join in from both sides. After that, Europe and Africa might link up with the Americas, and boom, Orica. And finally, Amasia. It might form if some of the tectonic plates go north. They can take continents like Africa and Australia along for the ride. They'll be hanging out around the North Pole. All the continents except Antarctica might come together. And even though they might gather around the North Pole, they won't close off the oceans. The Atlantic and Pacific Oceans would still be open for business. How this grand reunion happens depends on the Earth's tectonic movements. So far, we believe that Novo Pangea is the most likely scenario. It also depends on what exactly happened to Pangea after it broke apart. And when the new supercontinent appears, what's going to happen with the weather? How will the ocean behave? And what about the animals and plants? These questions all light up our minds. Who knows? Maybe someday our descendants will look at the world map and see this incredible journey come full circle. So keep asking curious questions and stay tuned for the next 100 million years.
7,500 years ago, the Pacific floor collapsed. Massive landslides buried the seabed in seconds. Fast forward to today. Robot subs have examined the place. Scans have revealed proof of at least 10 distinct cyclical mega-quakes. Now, researchers warn, the plates are still locked and building pressure, even today. If they start moving, that could trigger new red alert earthquakes and send disastrous tsunamis toward the coast. Let's look at the map. The fault here is like a giant zipper. It's over 600 miles, stretching from Northern California to Canada. It's called the Cascadia Subduction Zone, and it's a part of the Ring of Fire. You know, the famous giant horseshoe around the Pacific that can serve as your where-to-go reminder if you're into volcanic and earthquake tourism. One of Cascadia's biggest events happened around the year 1700. There are no local written records of it, but there is a story. A well-known indigenous legend tells of an epic battle between a thunderbird and a whale. In the story, the thunderbird's wing beats make the ground shake. The whale's thrashing sends seawater flooding inland. The Thunderbird wins by finally grabbing the whale and slamming it back down, shaking the land itself. Many researchers believe that this legend originated from the real earthquake of 1700. But we don't just have cool myths to give us the full picture. In the early 1700s, samurai officials recorded waves flooding villages and rice fields. But nobody felt the earthquake that must come first. That's why they nicknamed this event the Orphan Tsunami. But it did have a parent, and it took scientists 300 years to finally connect it back to Cascadia. To see Cascadia's past, researchers sent robot subs to scan the bottom in crazy detail. They expected to see a simple crack, but what they found looked more like giant underwater steps. Some of those steps are about 33 feet tall, like a 3-story building. That only happens when a big piece of the seafloor snaps off, breaks loose, and slides all at once, not slowly. When that happens, it kicks up a mud avalanche. Picture a jar of dirt and water. Shake it hard, and a fresh layer settles at the bottom. Each layer is basically a timestamp from a huge quake. When scientists counted and dated them, they found 10 separate mega-quakes that hit one after the other over thousands of years. That means that Cascadia doesn't let pressure out little by little. It stays stuck for a long time, then suddenly breaks out violently. That pattern is why the Cascadia subduction zone is considered one of the scariest fault systems in North America today. So what's actually happening down there? The plates aren't sliding smoothly, they're stuck. And while they're stuck, the coastline is getting quietly bent out of shape like a ruler you're flexing in your hands. It doesn't look dramatic day to day, but it's been loading up for centuries. When that tension finally snaps, the coast will instantly drop. Geologists call this co-seismic subsidence. We're talking about the ground plunging 6 to 8 feet vertically in a matter of minutes. Imagine standing on a beach. The shaking stops, and you realize the ocean is rushing in. Not just because of a wave, but because the land you're standing on has physically sunk below sea level. That one move is enough to shove the seafloor out of position and force the ocean above it to react. Cascadia can produce a magnitude 9.0. That's top tier, categorized as the most destructive natural event that can happen. It can shake the ground for minutes, pushing and pulling everything back and forth until buildings and bridges start falling down. A 9.0 class quake also means the seafloor is vibrating and shifting, lifting in some spots, dropping in others, all in one sudden motion. A tsunami starts when the seafloor moves and pushes a huge amount of water out of the way. If the bottom suddenly lifts or drops, the water above it gets displaced instantly. That water has to go somewhere, so it races outward in every direction. Out in deep water, that wave is rarely tall. It spreads out across a long distance, so it can pass under ships without anyone noticing. The danger is speed. In the open ocean, tsunamis can travel around 500 to 600 miles per hour. That's like traveling from New York to Detroit in 60 minutes. Eventually, the ocean starts to pile up, getting taller by the second. Near shore, it can stack up to tens of feet, and in extreme cases, it can run up to 100 feet on land. It swallows the coast, then drags everything back to sea with a violent tug before the next hit arrives. But that's not all. When the fault snaps, it often triggers massive underwater landslides. When a huge chunk of seafloor collapses, it can shove water locally, like dropping a boulder into a tub. In the Cascadia subduction zone, you aren't just dealing with the earthquake's kick. You're getting a 1-2 punch from the shifting crust and the crumbling slopes combined. On parts of the Oregon coast, emergency experts say the shaking could last 5 to 7 minutes, long enough to realize what's happening and still won't be over. Then comes the scariest part. In some places, a tsunami can hit in 15 to 30 minutes. Remember, the earthquake is a warning. If you're on the coast and you feel strong, long shaking, you do not need to wait for a text alert or a siren, or someone on the news to yell tsunami. During the tremors, the basic recommendation is to literally drop to the ground, cover, and hold on, staying away from windows and chandeliers that can fall on you. As tempting as it is, we shouldn't stop to make a reel out of the situation. Before anything happens, make one decision while your brain is calm. Pick the closest high ground and go for it. Not somewhere uphill, an actual spot. If you ever needed a reason to learn your neighborhood, this is it. Your instinct might say, get into the car and drive. But don't. Roads are probably jammed and bridges could be damaged. People who live on the coast already know to keep it practical, with shoes on the bed and a go bag prepared just in case. The danger doesn't end with the first impact because the tsunami waves, well, they come in waves. The initial hit is rarely the largest, and the ocean can continue to pulse in and out for hours. This creates a violent tug-of-war. The receding water acts like a massive vacuum, dragging anything caught in the backwash out to sea. Japan's 2011 disaster is the most recent vivid example of what a magnitude 9.1 can do. The seafloor shifted in a single massive heave, and minutes later, the ocean literally rearranged the coast. A huge wall of water crashed inland, reaching over 100 feet high in some spots, and turning the coastline into a conveyor belt of debris. It was like water turned cars into giant bowling balls and shipping containers into massive metal bricks, smashing ports and drowning low-lying airports and electrical substations. Finally, what do officials say about the timeline for the possible next disaster hitting Cascadia? Well, they can't give us precise dates, but they did announce some odds. For the biggest, scariest earthquake possible, the United States Geological Survey says there is about a 10% to 15% chance it'll happen in the next 50 years. Chances for a quake that isn't the mega version are 1 in 3 in the next 5 decades. Those odds are actually pretty high. But here is why it isn't all that grim. Scientists know this isn't random. Cascadia has a pattern, and patterns are what preparation runs on. We already know how to build for big shaking, and we're getting better at spotting where stress is building. It doesn't mean we can stop the earthquake, but it means we're getting way better at knowing what to expect. In the meantime, just keep a go bag by the door and maybe take a walk around your neighborhood every once in a while.
Consider South America and Africa. Don't they kind of look like they fit together, like puzzle pieces? Well, they actually did. But about 130 million years ago, South America was like, bye, and slowly started drifting away. These days, it's around 1,800 miles from Africa, and it's still on the move. Every year, the continent shifts a little more toward the Pacific Ocean. So, how's that even happening? Tectonic plates are constantly moving. That's what makes the Earth's surface shift over time, going from this to what we see today. But those movements happen so slowly that you and I can't see them go. So, no, Brazilians or Chileans aren't out there feeling their continent inching westward. But the numbers don't lie. South America is moving, and apparently all it wants is to get as far away as possible from this massive underwater mountain range called the Mid-Atlantic Ridge. But what exactly is pushing the land toward the Pacific Ocean? It is the heat inside our planet. Way, way down beneath the ocean, there are cracks in the Earth's crust, and magma, super hot melted rock, rises up through those cracks. When that happens, the magma cools and hardens into solid rock. Over time, this process might build underwater mountains, like the Mid-Atlantic Ridge. And as more new crust forms, it begins to push the older crust out of the way. In the process, tectonic plates and the continents riding on top of them get pushed along. Now, on the other side of South America, over by the Pacific, there is the Nazca Plate. It's heavier and it's moving eastward. Since it is denser, it is sliding underneath the South American plate. This entire process is called subduction, and it's happening at a rate of about 3 inches per year. By the way, the collision between these two plates is what's behind all those breathtaking volcanoes scattered throughout the Andes, and it's also making the continent move. So, if everything goes according to plan, projections show that South America will end up more centered in the Pacific Ocean in the future. But some models suggest something way crazier. Before we get into that, though, we need to clear something up. Why on earth isn't Africa following in South America's footsteps? I mean, shouldn't it be drifting west too? Well, not quite. Africa is doing its own thing because it sits on the African plate. So the mid-Atlantic ridge is located between those two continents, and just like it pushes the South American plate, it also pushes the African plate, but in the opposite direction. It's like this ridge is trying to split up two ex-besties, you know? But there's more. Africa is also being influenced by the East African Rift. That's one of those massive cracks we talked about earlier, but it's happening on land, which makes it extra dramatic. This is what's causing the continent to slowly split apart. It's a long story, but let's just say the rift is pulling Africa in more directions than South America ever had to deal with. Okay, now it is finally time to talk about that crazier thing that might happen to South America and everything around it in the future. Theory number 1. It could break away from North America. I know, super dramatic, but don't panic. We're talking hundreds of millions of years from now, and I won't be around. You see, both continents are moving in the same general direction, but at different speeds. The North American plate is cruising along at about 1 inch per year, while South America is moving a bit faster. So even though they're heading the same way, they are not keeping pace. Over time, as the Atlantic Ocean continues to widen and the Pacific keeps shrinking, all this tectonic movement could eventually pull the Americas apart. Theory number 2. Marine life could go through some major changes. Right now, the Americas act as kind of a giant wall between the Atlantic and Pacific Oceans. Because of that, sea animals have evolved differently on each side. Take the green sea turtle, for example. The ones living in the Atlantic tend to be bigger and lighter in color. Meanwhile, their Pacific cousins are usually smaller and darker. But if, one day, there is no land blocking these two populations from mixing, they would end up with brand new migration routes, new nesting spots, and a lot more overlap in their territories. Now, multiply that scenario by hundreds of other species, and things could really get shaken up. We're talking about new interactions, unexpected competition, and maybe even the rise of entirely new species. Alright, theory number 3. America might meet Africa again. Right now, the Mid-Atlantic Ridge is busy creating a new seafloor, and because of that, the Atlantic Ocean is slowly getting wider. But in about 125 million years, scientists believe that process could come to a stop. Instead of the seafloor spreading apart, the ocean floor might start getting pulled under the continents. When that happens, the Atlantic will stop growing and start shrinking, and the water section between South America and Africa is likely to be the first part pulled beneath the land. That means the Americas and Africa could meet again. And when that happens, border countries could turn into super shaky places, with earthquakes happening all the time and brand new volcanoes popping up left and right. The eastern United States would no longer be known for the peaceful green slopes of the Appalachians, but for snow-covered giants that occasionally spew lava and ash, more like the Cascade Range out west. Countries would end up with totally new neighbors. Brazil might line up with Nigeria and Cameroon. Uruguay could be sitting right next to Angola. And Argentina might be sharing a border with South Africa. So if these two continents really do merge, how intense would that be? Well, for starters, this new supercontinent would instantly become the biggest one on Earth, about 1.5 times the size of Asia. And chances are, a brand new mountain range would form right where the continents meet, creating a natural border between nations. Being part of the same massive continent could make a lot of things way easier. For one, tourism could totally take off. People traveling between countries by land without needing pricey plane tickets could be a game changer. But it wouldn't stop there. Other types of economic activity could get a major boost too. Now on one side we have South America, which already produces and sells a wide variety of foods, from wheat to bananas, beef, cocoa, soybeans, hey, you name it. On the other side, there is Africa, exporting things like textiles and clothing. That alone would make them a super powerful bloc when it comes to trading raw goods. But can you name another important thing these two continents have in common? Yep, petroleum. Countries in South America, like Brazil, Venezuela, and Colombia, are major oil exporters. And over in Africa, you've got Nigeria, Algeria, and Libya doing the same. Now, can you see just how powerful that kind of union could be? Meanwhile, let's talk about animals. These two massive lands coming together could lead us to wild meetups, like a capybara sharing space with a Nile crocodile, or a sloth seeing a hyena from the top of a tree. This could even lead to new animal hybrids showing up, like a cabby crocodile or a sloth hyena. Okay, those weren't the cleverest names, and honestly, these animals wouldn't be able to mate or even wouldn't want to. But you get the point, right? It's not all positive, unfortunately. New species showing up could become predators, competitors, or even parasites to the native plants and animals. It would take a long time for things to settle into a new balance in those border regions. But honestly, no one really knows how long it would take. The only thing I do know is neither of us will be around to see it, which is okay.
Something is about to reshape the entire future of the West Coast. The coastline, the infrastructure, the whole map. Scientists fear there is not one but two big earthquakes coming, one caused by another. This wasn't even on the radar for most people, but new research is changing everything. For decades, everyone treated the San Andreas Fault and the Cascadia subduction zone like two separate monsters that just happened to live in the same neighborhood. They were powerful, yes, but independent. But now, scientists believe these two giant faults are mechanically linked, and one can literally pull the other into rupturing shortly afterward. Cascadia moves, San Andreas moves. San Andreas tears, Cascadia tears. And the potential consequences of that are honestly haunting. Scientists found evidence that it happened at least 10 times in the last 3,100 years. Earthquake, pause, earthquake. It comes from marine sediment cores, which are like time capsules pulled up from the ocean floor. Researchers analyzed layer after layer of seabed sediment and found doublets. Paired debris layers created by two massive quakes happening so close together that the ocean barely had time to settle between them. That discovery takes us to the Mendocino Triple Junction, the geological troublemaker of the West Coast. It's the place where three tectonic plates crash and grind into each other like badly aligned gears. It's also the zone where the San Andreas meets Cascadia, which makes it the perfect place for these double quakes to form. The stress changes caused by a rupture in one fault travel straight through this junction and destabilize the other. It's benign when it happens to a bookshelf. When you move one book, three others shift. But when you think about it like a coastline with millions of people, entire cities, major infrastructure, it instantly feels terrifying. To many people who live on the West Coast, the San Andreas kind of feels like a California's problem, and Cascadia like an Oregon and Washington's problem. But when you understand that these two faults can essentially fire at each other, it stops being a local issue and becomes a continental one. A Cascadia mega-quake alone can hit magnitude 9.0 plus, rip open 600 to 700 miles of seafloor, and send a tsunami roaring toward the Pacific coast. And it could just be the first quake, and then, maybe minutes later, the San Andreas snaps in Northern California. The shaking could ripple down the state like a zipper tearing open a jacket, and if it goes the other direction, it could be just as bad. If the San Andreas ruptures first, the intense stress redistribution can destabilize the Cascadia subduction zone. You could get the California quake first with buildings rocking, highways breaking, and power stations failing. And then, soon after, the ocean pulls back in Oregon or Washington. And the 20-minute countdown to a tsunami begins, a follow-up disaster. It's the kind of chain reaction you don't want even in a video game, let alone real life. This discovery also tells us something eerie about the earthquake in 1700. the one that sent a tsunami across the Pacific so huge that it struck Japan with no warning. Japanese fishermen called that wave the orphan tsunami because it arrived without any felt shaking. Only centuries later, scientists figured out that it came from the Pacific Northwest. But until recently, no one knew that the San Andreas might have felt that event too, and it possibly slipped or destabilized because of it. So, the whole West Coast may have moved together. And we've come to the scariest part. All this isn't about if, it's strictly about when. The faults have a rhythm, a pace, and a geological heartbeat. We've seen how they behave across thousands of years. We know what they did, and now we know they sometimes do it in sequence. The real fear isn't the first quake. California already expects a big one. The real fear is the second quake, the one that comes before you've checked on your family, before emergency responders regroup, before the power comes back, and before the dust settles. Even if you don't live on the West Coast, this matters for you too. The ports in California, Oregon, and Washington handle a massive chunk of America's imports. Knock them offline, and it's not just the coastline that feels it. The ripple hits the entire country, and potentially the world. Grocery prices spike, supply chains freeze, gas availability dips, shipping timelines go nuts. The world is much more connected than any of us thought, and a geological double punch on the Pacific coast wouldn't stay a local disaster. It would spread, thread by thread, into everyone's life. So, those in power must prepare not for one giant rupture, but for two. Emergency plans, evacuation routes, response times, and power grid designs, all of it needs updating. Because nature has now shown us what even a single major rupture can do to a modern economy. It happened in Japan in 1995, on January 17th at 5:46 in the morning. The quake hit right by the northern tip of Awaji Island, only 12 miles from Kobe, a huge, busy city with about 1.4 million people back then, and another 2.6 million in Osaka nearby. The rupture ripped along the Nojima Fault for about 25 miles. That doesn't sound like much until you realize entire buildings can't survive that kind of sideways shove. More than 5,000 people lost their lives. 43,000 were injured. Nearly 400,000 buildings were irreparably damaged. This disaster hit one of Japan's largest industrial zones. And when you mess with a place like that, the shock doesn't stop at the shoreline. The damage was $200 billion US in losses, from smashed buildings and infrastructure and many businesses shutting down. Kobe's port just collapsed. Only 30% of the Osaka-Kobe railway lines worked. Part of National Route 28 literally vanished into the ground. Schools, hospitals, and municipal buildings, 85% of them took damage or were unusable. Fires broke out across Kobe, almost 300 separate incidents, burning the equivalent of 70 US city blocks and taking another 600 to 700 lives. Almost 100,000 people permanently left the region, 2.5% of the whole population gone in less than a year. And here's a detail that stuck with me. So many bridges failed that engineers suddenly had to confront how poorly older designs handled lateral shaking. Houses with heavy tiled roofs, built to fight typhoons, crumbled because all that weight sat too high. But the newer homes made after the 1981 building code revision stood. And that's when Japan realized that modern seismic standards were crucial to follow. Japan threw $58 billion US into restoring the region. Power came back in days. Roads and rail returned in 5 to 8 months. The main expressway took 21 months. The port was fully rebuilt in just over 2 years. And by then, all debris was cleared. Within 15 months, manufacturing jumped back to 98% of its old level. Stores reopened. By 1999, Kobe's economy reached roughly 75 to 90% of pre-quake levels. Japan overhauled its disaster management system entirely. They set up the Central Disaster Management Council and rewrote building codes. They upgraded everything from emergency drills to fire-resistant city layouts, and they launched the Earthquake Early Warning System that now gives Japan those precious few seconds before shaking hits. the same system that saved countless lives since 2007. But despite all this improvement, the Kansai region still sits on dangerous ground. The Roku Awajishima fault system, the same one that snapped in 1995, still runs under them. The 2018 Northern Osaka quake and the 2024 Noto Peninsula quake reminded everyone that this threat didn't disappear, it just waits its turn. A future large event on that system could hit even harder simply because the region has grown more complex, more interconnected, and more economically loaded. So Kobe wasn't even a triggered double fault rupture, but it still broke a major industrial hub, reshaped a national economy, and permanently changed global shipping routes. That's why when scientists started talking about two joint faults firing off back-to-back in Cascadia and San Andreas, you don't even have to imagine the consequences. We already got a preview in 1995. The floor is lava! Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help!" Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the end game here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping. rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first. On January 26, 1700, one of the biggest earthquakes in history hit off the coast of the United States. It had a magnitude of 9, which puts it in the top 10 most powerful earthquakes ever recorded. This earthquake triggered a huge tsunami and changed the coastline all the way from southern British Columbia down to northern California forever. Back then, the area wasn't very populated, but thanks to some clever research, scientists figured out exactly what happened that day by looking at old geological records, tree rings, and even some history from Japan. On the same day as the earthquake, a massive tsunami also hit Japan's eastern coast. For a long time, no one connected the two, but in the 1980s and 90s, researchers realized the tsunami in Japan had been caused by the earthquake in the Pacific Northwest. They were also able to pinpoint the exact day, January 26, 1700. They even found old trees in coastal Washington that had all perished around the winter of 1700, which matched up perfectly with the timing of the earthquake. The earthquake came from the Cascadia subduction zone, a fault where the Juan de Fuca plate slides under the North American plate. This fault stretches about 700 miles, from northern Vancouver Island in British Columbia to Cape Mendocino in California. The pressure from the moving plates builds up over time, and eventually, another big, devastating earthquake will hit the same region. It's just a matter of time. By looking at the geological records, past tsunami deposits, and signs of land level changes, scientists can figure out how often these huge earthquakes happen. Emergency planners have been preparing for the next big quake, often calling it the big one. Scientists believe earthquakes in the Cascadia subduction zone happen every 200 to 1,000 years, and since the last major one was over 300 years ago, the Pacific Northwest is definitely due for another. When it happens, the earthquake is expected to be as big as the one from 1700, but this time, it'll affect around 15 million people. The devastation will be severe. Buildings will collapse, roads and runways will crack, and bridges will fall. Communication in and out of the area will be cut off. But the worst part? The earthquake will trigger a massive tsunami that might hit parts of the Washington coast in as little as 10 minutes. It's not a matter of if, but when the Cascadia subduction zone will break. When it happens, it will be the worst disaster the US has ever faced. Worse than the Hurricane Katrina or Superstorm Sandy. It'll impact an enormous area, stretching from southern British Columbia all the way down through Oregon to northern California. That means millions and millions of people will be affected. Fairchild is considered a backup staging area for handling the aftermath of the earthquake, with Grant County International Airport in Moses Lake being the main one. For those who will survive the initial quake and tsunami, the aftermath could be just as disastrous. Aftershocks will follow, and transportation will be a mess. Roads will be damaged or completely blocked, airports will shut down, and most of the main routes, like Interstate 5, will have bridges destroyed. This means food and water supplies will be cut off, and it will be incredibly difficult for help to get in or for people to escape. Gas pipelines will most likely be damaged too, and restoring them could take anywhere from a few days inland to weeks or even months along the coast. Power outages will be widespread within 100 miles of the coast throughout the entire Pacific Northwest, and water could be out for 3 to 7 months. Even telecommunications will be down for 2 to 3 months across the Pacific Northwest, Alaska, and even parts of East Asia. The good news for eastern Washington is that it will mostly avoid the worst of it, thanks to natural barriers between the west and east sides of the state. The tsunami may hit the Columbia River Gorge, but it will lose energy quickly because of a sandbar under the river. The Cascade Mountains will absorb much of the earthquake's impact, so the east side won't feel it as strongly. And since eastern Washington won't get hit as hard, It'll be up to them to handle the aftermath of the quake. That means helping Western Washington, taking in refugees from the areas that got destroyed, and delivering supplies to where they're needed. Scientists have looked at other major 8.0 to 9.0 magnitude earthquakes like the ones in Chile in 1960, Alaska in 1964, and Sumatra in 2004, and Japan in 2011. These kinds of quakes can shake the ground for anywhere between 6 to 10 minutes, and that's a long time for the ground to be shaking. Such quakes are super intense because they happen close to Earth's surface, so it's not just a quick shake. It's a long, strong one that can cause a lot of damage. If the Cascadia earthquake and tsunami were to hit tomorrow, over 13,800 people could lose their lives, and about 107,000 people could be injured. The economic toll in Washington, Oregon, and California could top 70 billion. To put that into perspective, we can compare these numbers with some other major earthquakes. In Chile's 1960 earthquake, about 1,650 people lost their lives. The 1964 Alaska quake resulted in around 140 lives lost. The 2004 Sumatra earthquake and tsunami took the lives of an estimated 280,000 people. And the 2011 Japan earthquake and tsunami caused over 20,000 casualties. Authorities know about the dangers of the Cascadia fault, but even with all the planning, no one can say for sure what will be needed when the big quake hits. Right after the earthquake and tsunami, the areas outside the immediate disaster zone won't be able to help much because roads and airports will be destroyed, and resources will be limited. How can we deal with this kind of disaster and its effects? We don't have all the answers yet. Right now, let's focus on the Cascadia subduction zone. It's a huge fault line that stretches about 620 miles from Vancouver Island to Cape Mendocino in California, sitting about 93 miles off the coast. It's like one tectonic plate is slowly sliding under another. When the plates are close to the surface, about 18 miles deep or less, they get stuck because of friction, kind of like pushing two rocks together. Over time, this creates a lot of pressure. When the pressure finally becomes too much, the plates slip, causing a massive earthquake. This is called a mega-thrust earthquake, and it can be huge. Below the area where the plates are stuck, there's a zone where the plates move really slowly. We're talking about just a few inches every few months. This slow movement helps to release some of the pressure, but it also builds up more pressure on the parts of the fault that are still stuck. This means that over time, it increases the chances of a huge earthquake happening. These massive quakes, called Great Subduction Zone earthquakes, can be stronger than magnitude 8.5. Megathrust earthquakes are the biggest earthquakes that happen. They can go over a magnitude of 9.0, which is insanely powerful. Just to put it in perspective, a magnitude 9.0 earthquake releases 1,000 times more energy than a 7.0 and 1,000,000 times more energy than a 5.0. These earthquakes happen when a lot of pressure builds up in a part of the fault that's locked, which means the plate can't move past each other. When that pressure gets too high, the fault finally ruptures, releasing all that built-up energy in one massive shake. The Cascadia subduction zone is super long. That's why if it were to rupture all at once, it could produce a large earthquake. Scientists have studied this region and found that about 18 miles below the surface, the fault is completely locked. The plates there aren't sliding past each other. But deeper down, the plates start to slide more smoothly, causing less friction. This is important because it tells us how much stress is building up in that locked zone, and how it could eventually lead to a major earthquake.
The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the new Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hotspots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, But every now and then, it throws in some lava flows or shoots up some moderately high fountains. Sometimes, you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not one, not two, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out. So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas Fault Line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas Fault Line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tajon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the U.S. around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis, but there's something it can cause more damage than the big one. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas fault line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put 2 and 2 together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed, but Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May, 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe. There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever mega-quake advisory. It happened because of a strong tremor on the edge of the Nankai Trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega-earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia subduction zone, and it stretches from northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the U.S. and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gerwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the tide. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, the people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from an earthquake, keeping the building safe. You have friends over for dinner. You set your drink on the counter and go help your friend set out some desserts. When you get back, you notice the liquid in your cup. It's sloshing around and the ice cubes look like ships on a rough sea. Now you feel it too. On the ceiling, the chandelier is swinging like mad. Then you hear someone scream, "Earthquake!" The house and everything in it is rocking back and forth. You try to run for cover, but the shaking keeps you stuck in place, fighting to keep your balance. The cabinets look possessed, and glasses and dishes fly out and smash on the floor. The bookshelves topple over, and everything hanging on the walls sways and falls off. You duck under the dining room table, trying not to get hurt on all those broken dishes. Yeah, you've been through earthquakes before, but none like this. Checking your phone? Typical, no signal. You can't believe what's about to happen. The screams get louder, and suddenly, the whole house collapses. The biggest earthquake ever recorded happened in Chile in 1960. Disaster came in the afternoon, just when everyone was out enjoying themselves. To cause serious, life-changing damage, you need to have a magnitude of around 7 or so on the Richter scale. This one was 9.5. This part of Chile is smack dab on the so-called Ring of Fire, the most active volcanic and seismic area in the world along the Pacific Rim. The initial shaking lasted around 10 minutes, and after 2 days, many aftershocks were still strong enough to set off a volcano in the south of the country. But that's not where it ended. The earthquake unleashed a series of tidal waves all over the Pacific Ocean, with some reaching over 80 feet high. The waves and earthquake were so strong that they even affected Hawaii, Japan, and the Philippines. It caused around $500 million $1960 worth of damage. Many were left homeless. Much of their infrastructure was smashed too. Buildings as far as the eye could see were toppled, and debris piled everywhere. Scientists estimate that this earthquake was so powerful, it shifted the Earth's axis, making our days 1.26 microseconds shorter. That might not seem like a lot, but think about it. Just one natural disaster was strong enough to make time move. Many of the coastal cities were flattened and floods were widespread. The economy spiraled downward. According to studies, if this earthquake happened today, it caused more than $20 billion in damages. So what would happen if an earthquake twice that size hit without warning? For starters, you'd likely feel the effects even further away. Tidal waves wouldn't just hit the coasts of Japan and the Philippines. They would move even further to China, Korea, Vietnam, and even Australia. And those waves would be significantly higher than 80 feet, perhaps double that. That's like 8 giraffes piled on top of each other, surfing your way. If you lived by the coast, you'd notice the waves. If you saw the water recede way back so you could practically see where all the fish call home, you'd know it was time to run. Chances are that a tsunami's heading your way. Say it really happens. You're caught under the wreckage, not knowing what's going on. You manage to free yourself and escape to the fresh air. And you're not alone, because all the houses in the neighborhood have turned into piles of bricks and rubble. The bridges have also collapsed, leaving people stranded on either side. You look around, dust yourself off, and rush to find help. Fire trucks and ambulances drive between the broken-down cars and rubble. You try to make it to your car, but the aftershocks are still hitting, and you're getting tossed to the sidewalk. With all the cell towers down, you can't call anyone on your phone. Your knees are shaking, but you manage to power through. Once you reach your car, you see it crushed under a boulder, like a giant soda can. You continue on foot and eventually reach downtown. It looks as if some giant got angry and knocked all the buildings down. You push forward and try to see if you can find some help. Without warning, your phone vibrates. You check it and see 1,000 notifications about a 20-magnitude earthquake. You're still shaking, but that's all you. The ground is still for now. Uh-oh. You hear something in the distance, racing towards you. To your right, you see tidal waves as tall as buildings charging at you. Still in shock, not knowing what to do, you now come to your senses and run. You don't even know which way to go. There's a tsunami right behind you, and in front of you are broken down buildings with rocks and concrete still falling everywhere. Wait, there's a building that's somehow still standing. You need to get on top of that thing. You reach the elevator, but it's jammed. Not surprising. You bolt up the stairs as fast as you can, tripping on broken glass and plaster, but always managing to get back up. You look out a window and see the water. It's so close. You're nearly at the top. A few more flights and… whoosh. The water forces its way into the building and drags you down at least 2 floors. You can barely see anything. Still, you know you must swim up. But the water keeps forcing you downwards. After about 30 seconds, you manage to swim your way out and continue climbing to the top. You scramble to the top floor and collapse on the roof. You're safe for now. The tidal wave is still going strong, plowing its way through the ravaged city center. Your phone is now waterlogged and useless. You have a perfect 360-degree view of your town covered in water and debris. The ground starts to shake again. Maybe you'll just sit around until this is all over, waiting for the rescue helicopter. But then, a loud explosion that almost breaks your eardrums shakes the ground even more. Off in the distance, smoke is rising, and soon it covers the entire sky. Darkness hides the morning sun. That's when you can see lava shooting up into the air and landing nearby. The lava forms into a river, flowing its way into town block by block. With this much seismic movement and the high intensity of the earthquake, the world's tectonic plates have shifted so that magma is pushing its way to the surface. From the earth, steam begins to vent. Then the heat hits you. You see the magma cover the ground like a blanket, eating up every car in its way. What's worse is that the magma is melting the foundations of the buildings that managed to withstand the earthquake and the tsunami. The buildings in the distance are now sinking and collapsing into the raging lava pool that's replaced your town. One by one, every building descends. That means, the building where you're standing is also swaying. It's about to fail. That's when you see the light. You look up and see a helicopter above in the distance. You wave your arms, run around, jump, anything to get noticed. And it works. The chopper makes a few circles and finally drops you a rope ladder. As you're lifted in the chopper, you take a good look at the world below you as it wriggles around like noodles in a strainer. You land a few miles out and are immediately treated by a doctor in an emergency triage center. You were one of the lucky ones. A year later, the tsunami water has receded. The lava that flowed inland has cooled. But all that magma permanently changed the ground below it, and the whole town is gone. The disaster has thrown the entire country into a financial nightmare that'll last decades. It takes months to survey the town, making sure there's no dangerous electrical wires or busted gas pipes anywhere. They're rebuilding your town farther inland from where the old one was. In other towns, they rebuild directly over the ruins. In others, they just decide to move everyone to a nearby city.
A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured. And when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega-earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long, and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse. All food chains would be broken. And only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe.
Get ready, because one of the Pacific Ocean's most active volcanoes might blow any minute now. Scientists monitoring Axial Seamount, a gigantic underwater lava factory just off the coast of Oregon, say it could erupt literally any time between today and early 2026 at the latest. Yes, it's underwater, but don't get tricked by the ocean's cover. This beast is almost 3 times taller than the Empire State Building. This volcano is inflating like a souffle at a Michelin-starred restaurant, and scientists are so excited they will live stream it. Seriously! So, here's the thing. This volcano will explode at any moment now because, well, it's inflating fast. Over the past few months, researchers have noticed that the seafloor is literally rising. It's like Axial is doing its best impression of a waterbed filled with molten rock. Scientists call this inflation, which sounds like something you'd complain about after Thanksgiving dinner. But in volcano terms, it means magma is piling up underground, causing the seafloor to bulge like a souffle that's this close to collapsing. Now, an underwater volcanic eruption might not sound so exotic. After all, most volcanic activity on Earth happens under the sea. Believe it or not, there are more than 1 million submarine volcanoes quietly churning lava beneath the waves as you watch this. The ocean floor is Earth's biggest volcanic hotspot. What makes Axial Seamount so thrilling is that it's under intense scientific surveillance, unlike any other underwater volcano. It's like the star player in a volcanic reality show, with a network of ocean-bottom instruments giving researchers real-time updates on magma movements, seismic tremors, and crust deformation. In fact, Axial Seamount hosts the world's first-ever underwater volcanic laboratory. Scientists have been keeping a constant eye on it since the 1990s, when they installed sensors that now relay live data straight from the seafloor. This kind of monitoring is unheard of elsewhere and has turned Axial into a geological celebrity, one whose behavior we can track with remarkable precision. Besides, Axial is hilariously predictable. It erupts roughly every decade, and right on cue, it's gearing up for another performance. By mid-2024, it had inflated to nearly the same level as before its last eruption, which means the countdown is on. Scientists are so confident in its schedule that they've set up a volcanic advent calendar, waiting for the day when Axial decides to pop. But hold on, Axial Seamount isn't just your average underwater volcano. It's got style, personality, and a geological identity of its own. Now, most underwater volcanoes, called seamounts, tend to look like cones or flattened domes. Axial laughs in the face of tradition with its unfashionably rectangular caldera, a 2-by-5-mile crater that looks like it was designed by a geologist with a ruler and a grudge against curves. Most volcanoes opt for the classic circular look, but Axial, it went full avant-garde. This caldera is punctuated by fissures, vents, lava channels, and mysterious dome-like structures that rise hundreds of feet high. It's like the volcano's wearing a funky geometrical crown instead of the usual rounded hat. What's more, Axial's location is like prime real estate for geological fireworks. It sits right where two major forces collide, literally. First, it's on the Juan de Fuca Ridge, an underwater mountain range formed where two tectonic plates are slowly pulling apart, like a zipper being undone. Second, it's perched atop the Cobb Hotspot, a deep mantle plume that acts like Earth's sneaky magma espresso machine, pumping molten rock from deep inside the planet and fueling a whole chain of seamounts. To put it plainly, it's like the tectonic plates are reluctant dance partners, sliding away from each other, while the Cobb Hotspot acts as the DJ, turning up the heat and keeping the magma party going. This dual influence creates a complex plumbing system inside the volcano, with magma chambers filling, draining, and shifting in ways scientists are still trying to decode. The competition between the spreading plates and upwelling magma is what gives Axial its unique geological fingerprint, and it's also why this volcano keeps surprising us. Now, we said that Axial Summit isn't just a crater. The truth is that inside, the action gets even weirder and cooler. Well, hotter, but you get it. Axial hosts black smoker hydrothermal vents, which blast superheated water at temperatures exceeding 700 degrees Fahrenheit. This is no ordinary underwater hot tub. These vents create one of Earth's most extreme environments, where bizarre creatures thrive in total darkness and scalding heat. Giant tube worms, crabs, colonies of bacteria, and even octopuses live off the mineral-rich plumes that gush from these vents, forming ecosystems completely independent from sunlight and photosynthesis. It's like an alien world beneath the waves, thriving off the volcano's fiery breath. These vent communities are crucial to science, not just because they're strange, but because they may resemble the earliest ecosystems on Earth. Some researchers believe life on our planet may have originated in similar deep-sea hydrothermal environments billions of years ago. Studying them could also help us search for life on icy moons, like Europa and Enceladus, where similar vents might exist beneath their frozen surfaces. When Axial erupts, it's like a natural reset button for these communities. The lava wipes everything out, but within months, life comes roaring back. Proof that even in the most hostile environments, real estate is always in demand. For those worrying about tsunamis or coastal disasters, relax. Axial's eruptions are the underwater equivalent of a slow cooker. The immense water pressure keeps things chill, well, scalding, but not explosive. So the worst thing that happens is some lava decorates the seafloor, and a few crabs have to find new vents to squat in. This means no massive ash clouds or explosive blasts that could reach the surface. Instead, lava oozes out and spreads across the seafloor, sometimes traveling for miles. But for scientists, this eruption is the golden ticket. Understanding Axial's patterns could help predict eruptions elsewhere, even on land. Plus, its bizarre ecosystems offer clues about how life might survive on other planets. Not bad for a volcano that mostly just sits around looking rectangular. Still, the volcano's activity can be heard in the form of thousands of small earthquakes every day. Thousands! As if the volcano itself was groaning and creaking, preparing to burst open. Again, we won't feel a thing, but at least they'll help scientists track the magma's movements and the volcano's eruptive cycle. Now, one of the coolest parts of this story is that scientists are preparing to live-stream Axial's next eruption for the first time ever. Imagine watching an undersea volcano in action, live, as it's painting the ocean floor with fresh lava. It's like a front row seat to a natural fireworks display, thousands of feet beneath the waves. The live stream will come courtesy of the Ocean Observatory's initiative, which maintains a series of fiber optic cables linking Axial's instruments directly to shore. It's the Wi-Fi of the deep sea, and it's about to broadcast molten rock in HD. And there's another twist. Scientists have noticed a curious pattern in Axial's eruptions. All three of its most recent eruptions, in 1998, 2011, and 2015, happened between January and April, the months when Earth starts moving away from the Sun. So why? Well, it might have something to do with the Moon's gravitational pull. The Moon's orbit causes ocean tides to rise and fall, which changes the pressure on the seafloor and could help nudge the magma chamber to its breaking point. I guess the Moon isn't just a romantic light in the night sky. It might be the ultimate volcanic whisperer. So, one thing's for sure, when Axial goes, it'll be the best documented underwater eruption in history. So, keep your eyes peeled. This is one natural spectacle you won't want to miss. And who knows, if we're lucky, we might even get deep-sea eruption ASMR out of the deal. Now, if you'll excuse me, I'll be refreshing the live feed like it's a Taylor Swift ticket sale.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon
to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?